So this is a way to implement a 4-bit ALU. So these are our inputs A, B, C, D. These are the selections. Let's make them 0. These are the probes to show the output from the ALU. This is the carry from the ALU. These are the outputs. Now we have 3 registers A, B, and C. Each has its own specific clock A, clock B, and clock C. Then we have 2 output enables and 1 common clear. This is our tri-state buffer 1, this is a tri-state buffer 2, and these are the 4 buses we have: bus 1, bus 2, bus 3, and bus 4. So these are the flow of operations telling us how the things go in the system, how we should proceed after putting in our inputs. Now these are the instructions. So first we must make sure the output enables are both set to 1 and clear set to 0. And as output enable is 1 and clear is 0, output enable B is 1, and the clear, we have 1 clear, so it is 0. So if we have an output enable which is 0, then it will make the it won't let buffer to store anything, so we wouldn't get any output. If clear is 1, it will keep on clearing the registers and we won't get any output again. Okay, so the next thing we have to do is choose 2 4-bit values for the inputs. So let's take a simple value. Let's take 1. We'll toggle the clock A. Now this is the register 1 is storing 1. Now let's take another value, which is the state. Just take 2. Now we clock B. The register 1 is going to store 2 now. So now let's do some so now we have done this step. So now let's just select the values M and C, where M is the input mode something and C is the carry. Let's do an arithmetic operation first, where we take M as 0 and C as 1. So let's do that. M as 0 and C as 1. Now we have to use the selections or the selectors in order to do the desired logic or arithmetic, and this is the data sheet for it. So here's the data sheet. We want to as you know, M is 0 and C is 1, so let's just do A plus B. Now where is this? Oh, here is A plus B. For A plus B, S3 is high, SO is low, SO is high too, or S0 is high, and S2 and S1 are lows. So let's just do that. Well, 1 plus 2 is 3. Now this is the buffer here. Make sure output enable is 1, and it is, so everything is stored in the buffer now. And I'll just toggle clock C, and there you go. This is our output for the arithmetic operation. Now let's do a logical operation. Let's just take 7. Oh, sorry, 6. As let's take this value as the operation. Let's take this value, first input value. So we'll store it in clock A. We'll toggle clock A to store it in register B. Now let's just take this value and store it in B. Now we want to do a logic operation. This means M should be high, and the logic operation I'm interested in doing is ANDing them. So let's just do that. Make M high, and in order to AND them, the S2 should be low and everything else should be high. So let's just do that. S2 is low and everything else is high, and there is the answer. Now let's just clock C, and there we go. So this shows us that the 4-bit ALU works, and the buses and everything else works fine. And there's one note which I observed. as you can see, I'm using two different registers. Like I'm using three registers, and two of them are the D, and one of them is the N. So when I was using the registers D register for the last operation, it was giving me some garbage values. So as a user, just be careful. Don't use register D for the final output. Just use the N one. Thank you, I guess.